I'm going to show you how to solve these problems for review day 1. Just be nice to me because I'm going to use my page marker to do my problem solving, so my writing will not be pretty. Okay, so question number 1. Given this scatter plot, it says that the scatter plot shows the amount of money Ernie received selling 16 used lawnmowers. He drew a line of best fit to determine how much he should expect to receive when he sells a mower. Which is the best estimate of how much he should receive when selling a 7-year motor? So I'm looking at the scatter plot here, and this is his line of best fit. So what I'm going to do is go to the year 7, because that's how old it is, and it's approximately right here. I'm going to scoot over, and it looks like it's between 3 and 4, but I'm going to check to see how it's scaled, and it's scaled between tens of dollars. So that tells me that it's between $30 and $40. So I know, see, look at, that is not pretty. So 30 to, this should be a 3, $30 to $40. And I'm just going to find the best match for it. So between 30 and 40, it looks like I have between 30, 50, at least 50, which would mean it would be more than, less than 30, so less than the 30, between $2 and $5. So the best match on this one would be A. Okay, the next one, number 2, says which of the following best describes Ernie's findings? As the age of the mower increases by 1, the amount earned increases by 10. As the age of the mower increases by 1, the amount earned decreases by 1. As the age of the mower increases by 1, the amount earned decreases by 10. As the age of the mower increases by 1, the amount earned decreases by 13. So all of these tell me that what they're looking for is slope, because it's a change, it's a rate of change, and that's what slope represents. So I'm going to go up and I'm going to figure out what is the slope of this line. So here's 2 perfect points, point 1 and perfect point 2, and it looks like I go down 1, 2, 3, 4, 5. So I'm going down 5, over 1, 2, 3, 4. Down 5 over 4 is my slope. And then I'm looking, and none of it really shows down 5 over 1. This really represents down 5. Down 5 is in tens of dollars, so down 50 is really what that represents. Down 50 over 4. So let's try to find the best match here. This represents a positive slope because it says as it increases, the other increases. So that implies that the line's going up. So that is not it. As the age of the mower increases by 1, the amount earned decreases by 1. So my slope is down 50 over 4. I'm going to go ahead and see how much would that be, because this is dollar is to years. So this is kind of touching base with our 7th grade standards, proportional reasoning. So I'm going to figure out how much for 1 year. So it went down 50 over 4. This would be a proportion. I'm going to go 50 times 1 divided by 4. I'm just going to type that in here. 50 times 1 divided by 4 would be 50. Oh gosh, I got to move this. 50 times 1 divide 4, enter, it would be 12.5. So it decreases by 12.5 in a year. I'm going to see if that helps me at all. So as the age of the mower increases by 1, the amount earned decreases by 1. I don't think so, but I'm still not ready to let that one go. As the age of the mower increases, the amount earned decreases by 10. That's closer. Let me see the next one. As the age of the mower increases by 1, the amount earned decreases by 13. That is definitely the closest one. So I'm going to go ahead and choose D on that one. Okay, which of the following belongs to the set of rational numbers? So rational numbers is anything that you can turn to a fraction or a ratio of two integers. So as long as it's a perfect square root, because like the square root of 16, for instance, turns into 4, and 4 then can be written as a fraction, 4 over 1. So I'm going to try to find the square root that is perfect, because that would be the rational number. So just a reminder on how to do this with our calculator. We would go to this blue button here above the x squared, because that's a square root. So second square root, I think it was 79, and that's not a perfect square root. So I'm going to do the next one. Square root of 81 is perfect, so I know that that's a rational number. I'm just going to check to make sure that the other ones are not rational. Square root of 83 is not perfect, so that's not a rational number. And lastly, the square root of 85 is also not perfect. So my only perfect square is 81, so that's a rational. Okay, this one says let y equal negative 4x plus 9. If the value of the dependent variable is negative 2, what is the value of the independent? So you have to know the language of dependent and independent. Remember, if you recall making the charts, y depends on x. That's what the y equals. It's y depends on whatever x is. X is the one that we can keep changing, and y is dependent on when we go negative 4 times the x plus 9. So my dependent value here is negative 2. Y depends on x, so that means I know y is negative 2. So negative 2 is equal to negative 4x plus 9. So negative 4, and this just takes forever, but that's okay. Negative 4x plus 9. So now this is just a two-step equation. I'm just going to solve to figure out what my x value is. So I'm going to subtract. I'm moving what's not sticking to it first, so subtract my 9. Negative 2 minus 9. Remember, you're really plussing a negative there. So what you could do, if you think that's 7 or negative 7, you could always punch that into the calculator. This would be a calculator question. Negative 2. Remember to use this button for the negative. If you can't really see it very good, use this button for the negative. Minus 9. Enter, and that's negative 11. If you use this, negative, whoops, yeah, see, it just goes negative 2 minus 9. See, it's like answer minus 2 minus 9. It just doesn't make sense. You have to use this negative button down here. So anyways, that's negative 11. So negative 11 is equal to negative 4x. Negative 4. Bear with me again. I'm writing this with my cursor, so it's not as easy as it sounds. So the negative 4 and x are sticking together. That represents multiplication. So to move multiplication, we divide. So I'm going to divide both sides by a negative 4. So negative 11 divided by a negative 4. Punch that right in. Negative 11. Whoops. Negative 11 divide negative 4. Enter. And that's 2.75. Now you could keep it as its a fraction. That's more of an 8th grade standard. 7th grade, you keep it as a decimal or a mixed number. 8th grade, a lot of times you write it as the improper ratio. So if you wanted to change that to the ratio, you would go to math and you want to slide it to the fraction. That arrow means slide to fraction. So I'm going to slide it to the fraction, hit enter, and it's a positive 11/4. And if you would think about it, that makes sense because the two negatives cancel out. So that would be a positive 11/4. So I'm going to go ahead and use the age-appropriate way to write that down. Okay, this one says, which is the graph of y equals 3x minus 1? So I'm going to show you two ways to do this. Method number 1 is my knowledge of slope-intercept. Slope-intercept is y equals mx plus b. Let me go ahead and take forever to write this. Mx plus b. Remember, the m represents the slope, so this is my slope. I'm just going to write an S since it takes so long. And this is my y-intercept. So that's the vertical axis, the tall axis. I'm going to say y-end. So when I look at this graph, the actual equation, it's y equals 3x minus 1. So my slope is 3. So that means I go up 3 over 1. And if we plus a negative here, my y-intercept is negative 1. So this would be my y-end, my y-intercept. So I'm going to find the match just using my knowledge there. So I should be going up 3 over 1 and cross the y-axis at negative 1. So this one crosses the y-axis at negative 1, but it looks like I go down 1, 2, 3, down 1, 2, 3 over 1. So it's not even a positive slope, so that's out of the question. This one does not cross the y-intercept at negative 1, so again, that is not right. This one crosses the y-intercept at negative 1, and my slope is up 1, 2, 3 over 1. So yep, that one looks really good. I'm going to check, that's a star. I'm going to check my next one just to make sure I'm right. My y-intercept at negative 1, and it's not. It's way down there. So that tells me that C is right. And I'm going to give you another strategy if you wanted to. This would be a calculator question. So again, what you could do, I'm going to see if I can see both of them at the same time. What you could do is graph y equals 3x plus 1 in your calculator. So y equals 3x minus, hold on here. Y equals 3, and then I have to hit this for x, minus 1, graph it, and then you can find the match. Which graph looks like that one? Not this one, not this one. Yep, that one looks good, and this one, the y-intercept is way down there. So that's another strategy you could use. Again, when you use this strategy, it has to be in slope-intercept form. Y has to be alone in order to use that. Okay, next. This one I can't use a calculator, so I have to use my knowledge of Unit 7, which is our exponent rule properties. So we need to simplify the following exponential expression, 6 cubed over 6 to the 5th. So what that means is I have 3 6's on top and 5 on the bottom, and it is the division property of exponents. So you can rewrite this as 6, and since it's division, you subtract 6 to the 3, that's a 3, minus 5, which equals 6 to the, how do you like that 6? Let me make that a little bit prettier, to the negative 2. And then you can't ever, when you simplify exponents, you can't have a negative power. So I am going to move that to the bottom, and it's going to be 1 over 1/6 cubed. Just kidding, I don't know why I said cubed, I meant squared. And then 6 squared is easy to evaluate. 6 times 6 is 36. So final answer, 1 over 30. Let's see if I can write this good, 6. I'm sorry that my writing is so hard. Again, writing with a trackpad is no fun. So 1 over 36. I think I did tell Schoology that you could put 1 over 6 to the squared power. But if we can simplify fully, that's always the best. Okay, the next one. This is a linear equation, which means this would be your slope. It's what things are constantly changing by. And this is our y-intercept. So f of x is the same as y. Like y equals mx plus b is the exact same as f of x equals mx plus b. So this equation, f of x or y equals 0.05x take away 2 represents Ben's earnings each day on his paper route, delivering x paper. What does the slope represent? So this is my slope, and slope is your constant rate of change. So I'm going to see which one shows a constant rate of change. It costs Ben $2 for materials before delivers. That would be the initial cost right here, the -2. He earns money for each paper. Take away the $2 for him that he has to pay. So that's not slope. It costs Ben 5 cents for materials before he delivers. No, that would represent a negative. He's not earning. That would be a -5 cents. So that's not working. Ben earns 1/2 of a cent for each paper he delivers. No, I don't even know what that would look like. Ben earns 5 cents for each paper. Yes, because each paper, the word each represents multiplication, so that they should be sticking together, and it's his constant rate of change. So that one would be D. Okay, moving on to number 8. This one would be a calculator question. It says, what is the value of the expression absolute value of x, take away absolute value of y, if x is -5 and y is 8? So I'm going to do it with my knowledge of absolute values, and then I'll show you how you could use your calculator. So this would be the absolute value of -5. Okay, take away the absolute value of 8. It's so hard to do this. And again, what I did is I plotted my -5 in for the x and put my 8 in for the y. So absolute value represents how far from 0. So -5 is 5 from 0. Take away 8 is 8 from 0. So 5 take away 8 is a -3. So my answer should be -3. What you could do there with your calculator, there is this lovely in the math button. I think if you go to number, yeah. So again, let me show you. It's a math function because we have absolute values. So I go to like our math operations, and it's none of these weird things. And you could, if you didn't know, you could just see all that weird vocabulary in there. So we want to go to numbers. So I'm going to have to go all the way back up. Oh, maybe not. Okay, numbers. This abs means absolute value. So, and you can always guess and check. If you look, see, oh, it's only graphing, huh? Let me graph and clear this. Okay, math, absolute value, and I'm going to hit enter. So the absolute value of -5, and I'm going to show take away, go back to my absolute value of, what am I doing? 8. And you see, like when I hit that function, it went ahead and just turned those to absolute value. Hit enter, whoops, clear back, negative, I don't know what happened there, math, the absolute value of -5. Maybe you can't do an operation. You might have to hit enter. I'm going to try this one more time. Minus absolute value of 8. Get out of that function, hit enter. Yeah, it's not letting me. So what you could do is go to math, number, do your absolute value of -5, hit enter. Oh, it's because I was in it. Absolute value of -5. So -5, get out of there, enter, is 5. And then you could say take away the absolute value of -8. Oh, I know what I did. I used my negative sign on my computer, which is like the minus sign. That's why it said syntax error. And that is -3. So again, I'll show you what I did. I think I can do this all at once. So go to number, absolute value. I hit my dash in my computer. I can't do that. I have to hit this negative. So -5, get out of there, take away, and then absolute value of +8. Oh, it's +8 anyways. I messed up. Enter, and there it's -3. So my mistake there was I was using my computer for my negative sign, which represents minus to the calculator. So I had to make sure to put this minus, this negative sign. Okay, so anyways, that's how you do that, a roundabout way. Number 9, a boat rental agency charges $50 to rent a boat and $8 per hour of use. which is the equation that gives the total cost C of renting a boat for 8 hours. So I want to know what is my constant rate of change. So my constant rate of change is my $8 an hour. So that is what should stick to the variable, because I don't know how many hours I'm going. So it should be 8 times your hour, and then you have this random $50 fee to rent the boat, so you would add to it the $50 to rent. How do you like that 5? And that's 0. So 8 times the hour plus 50. This says that this one right here shows you it costs you $50 each hour. It's not just a one-time fee. This one says that each hour costs you $58, and that's not true. This one says that it's only $8 an hour and it doesn't count the one-time charge. So the only one that shows the one-time charge is that first one. Okay, number 10. A 25-foot ladder is leaning against a house. If the base of the ladder is 8 feet from the house, about how far up the house is the ladder? So this one, if you're confused, oh, and then I have round to the nearest whole foot. So if you're confused on how to handle this, even though we just had a little baby mini unit on it, you can always say, is there a formula I can use? It's an awesome avid strategy. So I look at my formulas that the MCA gives me, and I have Pythagorean, the distance formula, that one-day lesson we had, slope of a line, slope-intercept, point slope, standard, arithmetic sequence, geometric sequence. So this one I can use Pythagorean because it's a triangle. So I'm going to go ahead and use Pythagorean's theorem over this. So my right angle is right here. So I know that I should have x squared plus 8 squared should equal 25 squared. So x squared plus, I'm trying to write nice, 8 squared is 25 squared. 25 squared. So again, I showed you kind of my lazy strategy for doing this. I know I have to take away 8 squared. You could actually calculate these squared dimensions out, but your calculator will do that for you. So I'm just going to minus 8 squared to both sides. And I'll show you how I type that into the calculator. 8 squared. So I'm going to go calculator, and I'm going to go 25. There's the square button. Take away 8 squared. The calculator is going to do order of ops, so it's going to square them and then subtract them, and that is 561. So I have x squared is 561. Now x is not, that's a 2. Oh my goodness. Let me try to make that a little nicer. X squared is 561. So again, that's x is not alone. That is being squared. So I have to get rid of a square, and to get rid of a square, you square root. So x equals the square root of 561. And then I'm just going to show you that you put that down there. This takes too long. Okay, so I'm going to square root right here. So that's above the square. Square root 561, hit enter, and it tells me to round to the nearest whole. So I'm looking at the 6. The 6 tells me to go up, so it has to be 24. So 24 feet would be how high up it is. And check to make sure that it makes sense. Remember, the hypotenuse has to always be the biggest measure. So 25 is bigger than the 8, and 25 is bigger than 24. So yep, I'm doing good. Okay, so let's use, this would also be a calculator question, so I'm going to make this super easy. Use the order of operation. Which of the following expressions, when evaluated, will be 17? So I'm just going to go into my fancy calculator and type everything exactly how they have it. So parenthesis, 6 plus 2 parenthesis times 7 minus 3, enter, that's 53. And again, what I want it to be is 17, so that's not right. Okay, moving on to the next one. I have 6 plus 2 times parenthesis 7 minus 3. Notice that I type it in exactly how they have it. I put parentheses where they have parentheses. That's 14. 14 is not 17. Moving on. The next one, parenthesis, 6 plus 2 parenthesis times parenthesis 7 minus 3 parenthesis 32. So that's not it. So I go to the last one, which it has to be, but let's just double check. 6 plus 2 times 7 minus 3. Enter, and there's my 17. Yep, exactly like I want it to be. If you didn't use a calculator, you would just need to remember to do parentheses first. So this one would be 8 times 7, 56, take away 3, 53. This one would be 6 plus 2 times 4, and then you would have to times 4, 2 and 4, so 6 plus 8, 14. This one, you would do both parentheses and then times them, 8, 4, 8 times 4, 32, and that way you could solve it. Okay, number 12. A multiple choice test had 60 questions. 2 points were earned for each correct answer, and 5 points were deducted for each incorrect answer. Okay, I need to paraphrase this for myself. So I have 60 questions, 2 points for each right one, 5 points deducted, so negative, for each incorrect. Barry scored 64. How many questions did he answer correctly? So that 64 is a big key to me here. So I'm going to say that 64 for Barry, 64 is equal to 2 times each one he got right. That's a 2x. And then I have to have another variable here. I have to have his wrong ones. So I'm going to take away 5 points for each one he got wrong. And what I'm going to do is utilize the multiple choice questions. And then, so I know what he got right and what he got wrong. So, and then I'm going to find the match. So if he got 8 right out of 60 questions, that means he got 52 wrong. So watch how I type this into the calculator. That's a 52. So I would go 8 times each one he got right, it was 2. Take away 5 points for each one he got wrong, and each means multiply. So 5 times, what did he get wrong? 52. There's no way that one's going to be right. Yeah, look at, holy macaroni. He got in the negative. You can't do that. Okay, so then I have 48. If he got 48 right, it would be 48 times 2 for each point he got right. And then if he got 48 wrong out of 60, wouldn't that be 12? Let's just go 60, take away the 48 he got right, would be 12, yeah. So take away 12 times each one was 5 points he got wrong. So that's, oh, good gracious. 12 times the 5 points for each one he gets wrong, and I'll just type that in. So 48 times 2, and the calculator will do order of ops, so I don't even need to evaluate. 12 times 5, enter, 36. Okay, that's not it. 52. If he got 52 right, then he got, what, 8 wrong. So 52 times 2, and take away the points he got wrong. Oh, goodness. 52 times 2, I gotta be a little nicer here. Take away, and each one he got wrong, so he got 8 wrong, right? 8 wrong, and each one wrong was 5 points. And boy, that's quite the deduction. I don't think I love that. So I'm going to go 52 times 2, take away 8 times 5. So 52 times 2 points each, take away 8 wrong times 5 point deduction would be, enter, 64. I think I found it. What did he get? He got 64. Yes, we found it. So that was fun. Moving to the next one, number 13. So number 13 is kind of a doozy for me. I kind of struggled with it. I think what I'm going to do is end this session, because I'm not sure how long it's been recording, and then start a second half recording with number 13 so it doesn't take so long. So I'm going to do 13 on the next one. So again, this is for questions 1 through 12, and I'll do 13 next.